theta. Now I talked to you that we will see how to get the values of sine 0, cos 0 and sine 90 and cos 90. Actually this standard unit circle gives them. Okay, so this x-axis is nothing but what angle? 0 degree angle. So when theta will be 0, this is nothing but x-axis. So consider this point 1 comma 0. Now x coordinate is nothing but cos ratio. So cos of 0 is equal to 1 and sine of 0 is equal to 0. Thus we get for the 90 degree angle is nothing but theta equals 90 is nothing but y-axis. So coordinate corresponding is 0 comma 1. So x coordinate is nothing but cos ratio and y coordinate is nothing but sine ratio. So cos of 90 is 0 and cos of sine of 90 is equal to 1. Similarly we can get 180 degree and 270 degrees sine and cos ratio. So sine 270 sine of 180 degree, here y coordinate is 0 and cos of 180 is negative of minus 1. So minus 1, negative of 1, sorry, minus 1. And if you see for the 270 degree angle here, so x coordinate corresponds to the cos theta. So cos of 270. Now remember, positive angle is measured from in the anti-clockwise direction. So this is 90, this is 120, here is 270. In anti-clockwise manner you can get this as a negative of 90. So for that you must know angle. Further, if you want to know the radian system, radian angles, so any angle in the degree can be converted into radian by multiplying pi by 180 and that angle. So for example 90 degree is nothing but pi by 180 into 90, that is pi by 2 radians. So that's the radian system. Okay, so that's not the discussion point in this video. We are learning trigonometry. So remember this is 270 angle in the anti-clockwise manner. So this is x coordinate that corresponds to the cosine ratio. So cos of 270 is 0 and sine of 270 is minus 1. This is y coordinate. So the conclusion is that every x and y coordinate on the standard unit circle corresponds to cosine and sine ratio for the respective angle theta, and because of this fact these sine, cosine or trigonometric ratios in general are called as a circular functions. Okay, so I hope you get this is very important concept in the study of trigonometry. Okay, so actually the equation of this circle is x square plus y square equal to 1. In general, the equation of a circle is given by equation of a circle having a radius a and center on the origin is given by x square plus y square is equal to a square. Since the radius is 1, the equation for the standard unit circle is x square plus y square equal to 1. Now this is in the conic section part, but this is necessary to derive trigonometric identities, okay, that we will talk in the upcoming slides. Okay, so I hope you get this standard unit circle. We will see all the important conclusions that come because of this in the upcoming slides. So here is the conclusions. So that I told every point on standard unit circle gives values of cosine and sine ratios for corresponding angle theta. So x is nothing but cos A and y is nothing but sine A. Thus trigonometric ratios are also called as a circular functions. Now trigonometric identities can be obtained by with the help of standard unit circle. Now x coordinate is cos A and y coordinate is sin A, and the equation of standard unit circle, as I told, is x square plus y square is equal to 1. Substitute the values of x and y, we get cos square A plus sin square A is equal to 1, and this is first of 3 trigonometric identities. Now if you get it, divide by cos square A throughout, so cos square A upon cos square A plus sin square A upon cos square A is equal to 1 upon cos square A, which means 1 plus tan square A is equal to sec square A, because cos upon cos is 1, sin upon cos is tan, and 1 upon cos is sec. So 1 plus tan square A is equal to sec square A is the second trigonometric identities. And dividing this equation throughout by sin A, we get cos square A upon sin square A plus sin square A upon sin square A is equal to 1 upon sin square A, which is cot square A plus 1 is equal to cosec square A, which you can rearrange to memorize as 1 plus cot square A is equal to cosec square A is the third trigonometric identity, and the 3 trigonometric identities are required for solving problems. Okay, so they are quite frequently required to solve the problems. Okay, so I hope I hope you understood how to get them from standard unit circle by using concept of standard unit circle, that x is equal to cos A, y is equal to sin A, substitute and get these identities. Okay, now let us move to the next slide. So this is ASTC rule. Now in general, what we saw for 0, 30, 45, 60, 90, these standard angles lie in the first quadrant. Okay, so we saw the trigonometric ratio values for the first quadrant angles, standard angles. So from the concept of standard unit circle, again we saw that sine and cosine can be negative. So for example, sine of 270 degrees is minus 1, cos of 180 is minus 1. So trigonometric ratios changes their sign as per the quadrant, because in first quadrant x and y are both positive. Therefore x coordinate corresponds to cos A and y coordinate corresponds to sin A. Thus in Cartesian coordinate system, in first quadrant both x and y are positive, thus all ratios are positive, because according to the definition, if x and y, that means cos and sin, both are positive, then every ratio will be positive. Okay, now in the second quadrant, x is negative but y is positive. Now x coordinate corresponds to the cosine ratio and y coordinate corresponds to the sine ratio. Thus in the second quadrant only sine ratio, of course cosec, is positive, and in the third quadrant both x and y are negative. Therefore sine ratio as well as cos ratio is negative, cosec and sec are negative because they are inverse of sine and cos, and since tan and cot are the ratios of sine and cos, then negative of quantity upon negative quantity becomes positive. Thus tan and cot are the only two ratios that are positive in the third quadrant. And in the fourth quadrant, which is opposite of second quadrant, x is positive but y is negative. Now x coordinate corresponds to the cosine ratio and y coordinate corresponds to the sine ratio. Thus cosine ratio and inverse of that, that means sec ratio, are only ratios that are positive in the fourth quadrant. So if you see abbreviation of that, all, sine, tan and cos, you get a rule called ASTC rule. That means all ratios are positive in the first quadrant. In second quadrant only sine and cosec will be positive. In the third quadrant only tan and cot will be positive, and in the fourth quadrant only cos and sec will be positive, else all rest everything will be negative. Okay, so this is ASTC rule. That is again a conclusion that we can draw from standard unit circle. Now I'll show you, these are the standard angles 0, 30, 45, 60, 90 in the first quadrant. Sine, so let's make a table for sine, cosine, tangent, chord, cosec and sec ratios for them. Actually it looks pretty difficult to remember, but it's very easy. I'll show you a trick. So we know from the unit circle sine of angle 0 is 0 and sine of 90 is 1. Okay, also we studied with the help of geometry that sine of 30 is 1 by 2, sine of 45 is 1 by root 2 and sine of angle 60 is a square root of 3 by 2, that is root 3 by 2. Okay, now just remember the ratios for the sine values for the sine ratio, and now just write for to obtain the trigonometric ratios values for the cosine ratio. Just write them in the reverse order. That means write 1 here for the 90 degree answer. If for the sine is 1, just write it here for the 0 degree 1. Write the all values for the sine in the reverse order. That means 1, square root of 3 by 2, 1 by root 2, 1 by 2 and 0. Thus you get cosine ratio. Now take just division sine upon cos to get the tangent ratio. So 0 upon 1 is 0, 1 by 2 upon square root of 3 by 2 is 1 by root 3, 1 by root 2 upon 1 by root 2 is 1, thus tan 45 is 1, square root of 3 by 2 upon 1 by 2 is only root 3, and 1 upon 0 is infinity. Okay, to get the chord ratio, just write down the tan ratio values in the reverse manner. So infinity first, then the square root of 3, then 1 will remain same, and 1 by root 3 and then 0. Now to get cosec, just make inverse of sine. 0, 1 by 0 is infinity, 1 upon 1 by 2 is 2, 1 upon 1 by root 2 is only root 2, and 1 upon 1 upon root 3 by 2 is 2 upon root 3, and 1 upon 1 is 1. Okay, similarly you can get the values for the sec ratio by either writing the inverse of the values for the cos ratio, or you can write the cosec ratio in the reverse manner. For example, 1, 2 upon square root of 3, square root of 2 to infinity. Okay, so in this manner you can remember the table for the trigonometric ratios for the first quadrant. Now if you remember first quadrant values, then it will be very easy for you to get now, because in the later topics we will derive the trigonometric ratio values for all 4 quadrants. That means second, third, fourth quadrant we have to cover standard angles like 120, 150. There we will require this values to there we will require these values. So for the first quadrant you should be able to write this table. Okay, this is very important. So I showed you trick how to remember. Just write remember sine ratio, then write that in the reverse manner to get cos. Take a ratio tan, write that in the reverse manner to get chord. Make an inverse of sine and get the values for cosec, write that in the reverse order to get the values of sec ratios for 0, 30, 45, 60 and 90 degree angles. So with this topic we will stop here with this video, and next video we'll see some more